Hello, Neil here, and in this video I'm going to answer some questions about the fundamentals of AWS. You can ask me any questions in our Slack channels, details below. Let's get into it. What are the basic concepts in AWS? Well, AWS offers a lot of services, and this can be very overwhelming for a new user of AWS. So let's break it down into a simpler level. We've got object storage, block storage, compute, and networking. We couldn't really offer an internet service without networking. The network is what connects all the systems together, and also has some additional controls in there, such as security groups, a bit like firewalls, so you can control what can get to your stuff and what can't. And inside these sit security rules. As an additional level of protection, if you're just looking at the IP addresses specifically, there's ACLs or ACLs. All of these sit inside a VPC, a virtual private network. A virtual private network is a logical separation of network space that you can use for your services. Object storage in AWS is called AWS S3. S3 is short for SSS, or Simple Storage Service. It's the base level of storage you can have. It stores objects. An object is just a blob of data, and this is accessed via an index. In practical use, it means it does look like a website address when you're accessing the objects. S3 allows us to have public objects that anyone can access, or private objects, secured again with a different type of access control list. In the S3 scenario, it's a policy that we can update to control who and who cannot access certain resources. In S3, the resources are grouped into buckets. S3, a bucket is the name of where all the objects are grouped together. Amazon themselves use this as a base service for all of the data they need to store. AMIs, or machine images, configuration, websites and static objects, and data backups of all kinds. Block storage. This is what you might commonly refer to as a hard drive. Because we're dealing with virtual machines, the hard drives can be local, or they can be on a network. Block storage is referring to the network storage of this. In AWS, you can order a block storage device. This will then be mounted against one of your compute nodes. The current general purpose EBS volume is GP3. This is backed by SSDs and quite quick across the networks. The advantage of having an EBS and your data stored on the network volume is that it's attached to an instance that you decide. This means you can unattach it, destroy the instance, create a new instance, and then get your data reattached to the new instance. This allows us flexibility when creating a server. We don't have to have it on all day just because it's got a volume attached to it. Having EBS volume on the network also allows us to leverage this by saying we want a snapshot. Quick way of saying a backup. And because it's already on external storage, a snapshot can be taken in time and we can still access that volume while we're still using it, and the systems on the back end are taking a copy for us and storing it on S3. We don't have to know it's on S3, we just need to know that we've got a snapshot and that we can restore it. As well as the size, AWS also let us customize the IOPS, the input-output operations per second. This is a way of guaranteeing or reserving some of the network so that our instance can talk to our EBS volume at the speed that we specify. By default, the larger the volume, the more IOPS you get. With certain volume types, this can be tweaked to be higher if you've got a disk access program like a database where you need more IOPS. Compute. This is the brains. This is where the work happens. Basic servers like the M series have got a generic layout for the CPU and the memory. Generally, the bigger the number, then it doubles the CPU and the memory. On the other end of the spectrum are the T range. This is where we can have CPU credits, so we're not paying for a whole CPU, but just a portion of it. This greatly reduces costs, as we're really only paying for the memory. Some EC2 types come with ephemeral disk. This is a disk that's physically attached to the same machine that's running our VM. An often quoted feature of AWS is autoscaling. This is where you can have a standard image, an AMI, which we get from S3 as we know already, brings up a new instance, builds it from that AMI, boots it up, and is ready in about 3 or 4 minutes. Grouping these together into auto-scaling groups means that during high load, we can provision more of them, scaling up quite quickly, say to a Martin Lewis event or something like that. Not forgetting, of course, to have some statistics and some alarms so that we can scale down again when things get quieter. We don't want to spend that money when we don't need to. Talking of money, if you're watching a budget, then when you create EC2 instances, you can also create them as spot instances. This is where they're designed for short workload. I say short because the normal way of provisioning an instance is on demand. When you're paying on demand, you're paying a much higher fee, but you get that instance. As a spot instance, you're paying a much lower fee, but with the threat that it might get taken off you if a capacity is short on AWS's end. All of AWS's compute services are built on top of EC2. This includes the container services, Kubernetes EKS, ECS, the database services, and Lambda. In this series, we'll go through the other services that you can explore, such as ECS, the Elastic Container Service, a managed backplane for looking after containers, and load balancers, how we can control and funnel traffic to several instances in order to share the load. Particularly useful with the aforementioned auto-scaling groups. In the next video, I'm going to go into more detail about what is AWS Lambda. If you enjoyed this video, give us a like, and if you want to get notified of when that next Lambda video comes out, hit the subscribe button, and I'll see you soon.